This is part one on how the internet works on servers and clients, IP addresses, and domain names. So the purpose of this whole lesson, you might ask, why am I starting with how the internet works? Is because that's the foundation of our job. Most troubleshooting will boil down to understanding how the internet works and identifying where the problems are. So even if you have a very complex, what appears to be a very complex situation that appears simple from the user side, usually, like a patron says, I can't use this database. It's a very simple question. It can start to seem complex if you start trying to answer it because there are so many potential points of failure. The student could have a problem with their home network or their browser settings. There could be a problem on the vendor side. There could be a problem with the IT side within your college or university where they didn't configure their account correctly, so it can't get through the proxy, or there could be a proxy configuration problem. But no matter how complex it is, each of those points of failure is very simple to test and diagnose. It is an exchange of information from point A and point B. Is that information getting where it's supposed to go? And is it the right information? That's all you need to do. Go through step by step to isolate what has broken down. So this lesson and the one that I'll present next time will cover the basics of how information exchanges take place so that you can work out what has gone awry and answer that seemingly complex question with a, this is where it broke, this is the person who needs to fix it. So in this lesson, it's going to be the first three sections of that GitHub page. So servers and clients, which will include HTML, CSS, JavaScript, IP addresses, and the domain name system, including zones and records. So first, servers and clients. Before I started working in systems in general, servers seem to be this very complicated thing. If you look up like web servers, you see these photos of these very intimidating server farms, right? Lots of blinking lights. It's actually the whole internet, and the concept of servers and clients is kind of disappointingly basic. So the modern World Wide Web took shape in the 1980s at CERN. CERN is an acronym that's in French, but it means the European Organization for Nuclear Research. And Tim Berners-Lee is credited with the concept of the modern web because he used the word web in a paper. I think this was actually published in 1989. We had many siloed networks. So a lot of organizations had their own computer networks, their own documentation. And he said, can we link these all together so people can search this wide variety of information that exists? And he called it a web of notes with links, like references between them, using hypertext documents. And he said specifically that in 1980, I wrote a program for keeping track of software called Enquire, and it allowed one to store snippets of information and link to related pieces together in any way. To find information, one progressed via links from one sheet to another, rather like in an old computer game adventure. Enquire, although lacking in fancy graphics, ran on a multi-user system and allowed many people to access the same data. That's all the internet is. People accessing different documents that are linked together. And in this scenario that he's talking about, a multi-user system, that's more like an intranet situation. But now we have the internet where we want to get documents from a wide variety of places. So we use the term server and client to just simply designate who's providing the information and who's getting the information. So the basic English usage of these words, the colloquial example is when you visit a restaurant as a client, you place an order with your server and they deliver the food you requested. So it doesn't necessarily mean a machine in a big farm with lots of intimidating blinking lights, although those images are very cool. A server can be a wide variety of things. It can be a physical machine. Literally, your computer can be a server. Like your work computer could become a server, or even your personal laptop. Anything can be a server. It could be a virtual machine. So if you're using the Amazon Web Services, like EC2 instances, those are virtual machines. It's just one segment of a physical machine that is in a farm somewhere. Or they can be applications. It doesn't have to be an entire machine. So one example that is pretty common that you'll encounter in library school and in library projects is MySQL. That is an application that is a server. So the server is running on the machine, and then you interact with it through the client. And the client has commands like create database, like select these rows based on this criteria, insert new rows with these values in them. So client and server can be on the exact same machine as well. In web development, which is usually what we're interacting with as systems librarians, client typically refers to a web browser, so Firefox, Chrome, Edge, or one of the more niche ones if you have adventurous people as your patrons. And the server is the host machine, whether that's physical or virtual. And regardless of the server or client that we're talking about, all web pages boil down to three essential elements: HTML, CSS, and JavaScript. It might seem more complicated than that if you've heard about all these kinds of architectures that servers can have. People talk about Node.js and Python and Ruby and Cake and all these things that exist. It all boils down to HTML, CSS, and JavaScript by the time it's being interpreted by the browser. So I'm going to step through each of these and talk about them a little more. HTML stands for Hypertext Markup Language. That's the document type browsers display as a web page. Everything, no matter how complicated, ends up outputting HTML, and that's what the browser interprets. HTML consists of elements known as nodes with a start tag. For example, a div is one you'll see a lot. It contains some context and then contents in an end tag. If you've worked with XML before for library documents, it's similar. HTML is not actually a type of XML. It is a sibling of XML. They both came out of the same parent. Regardless, it's going to look very similar, follow a lot of the same rules. Start tag, stuff, end tag. So I'll be referring to those as elements or nodes. Might switch between them. They mean the same thing. And every document consists of a head, which contains metadata for that web page, and a body, which is the contents that is actually rendered for users. So here's an example of a very simple HTML document that I threw together for the course. It has a doc declaration that we're using HTML, start tag HTML, end tag HTML, and here's the head, start and end, body, start and end. So this title, page title in the browser tab, is something you will not see rendered on the page itself. Other things that you would see put in the head are references to links, other metadata meant to share with searching, like Google bots, telling it information about the web page, and CSS and JavaScript, which we'll get to in a minute. But you're not going to see this in the example rendered here because this is an iframe, which just shows the page contents. If you were to open this in a browser tab, you would see page title in the browser tab on the tab. Then the body contains the contents that you actually see. So this is a heading. It's H1, which is the biggest one. For accessibility reasons, you need to go H1, H2, H3, H4. That's how screen readers will interpret the hierarchy. And then you always wrap contents in some kind of tag, whether it's paragraph, which I have helpfully placed. This is a paragraph inside. Links are anchor tags, so A, with a reference there. And it says this is a link to the Orbis Cascade website. And this is how it renders on a web page. Big header is big by default. And these are using the default browser styles. You see, I have no styling in here whatsoever to show it, to tell it how to render this, how to display it. You do that with CSS, which stands for Cascading Style Sheets. And that tells browsers how to render the appearance of web pages. So you have rules like colors, font sizes, positioning of the elements and spacing between them, margins, padding, to position it visually on the page. CSS can be declared within a style element. This is usually in the header. It can be in the body. It's best placed in the header so that it applies to the entire, it makes sure that it is loaded before the entire web page loads. Otherwise, you might have weirdness. Or a linked file that contains rule sets based on selection criteria. So you might have seen snippets of this flying past on discussion lists on how can I hide this using CSS? How can I change the look of this? In Primo, there is a CSS file in your customization package that has a lot of these rule sets. And that's the linked file that tells the browser what to do. The style attribute, so that's within the node itself, not the contents of the node, but before the little brackets, you can add an attribute style that you can use to style individual elements and override global styles. So here's a short example. Within the head, I have added a style element, and I'm telling it within the body of the document, make the font family Times by default. For any paragraphs within a document, make the font family Arial. Change the color, the default color of the anchor tags or hyperlinks to this value. And then we're going to define a class called box that we're going to add a border and a nice gray background and some padding and margins. So you'll see when this gets rendered on the next screen, it's going to look different from the first example. I also made some adjustments to the contents so that you can see this in action. So as before, a big header, this is a paragraph, but it's going to be an Arial font this time because I put that in the rule. And this is a link to the Orbis Cascade website in teal. It's going to change color. And then here, where I had defined that class of box, I'm putting it in this element. So all of those styles that I defined as box, like the border, the background, and whatnot, are going to be on this one. And then here's an example of that attribute that is overriding the styles that I had previously set in the head, saying, change the background color to yellow instead. This is a value for yellow. And the border color to hot pink instead. So here's how it will render. There's that box, right, with the bright blue border that was initially declared in the head. And then here's the same box, but with some of those attributes overwritten. Then we have JavaScript. So JavaScript manipulates HTML documents. It can alter pretty much everything. Not everything, but pretty much everything. It can add and remove HTML elements, alter their contents and styling, trigger changes to the page on a user action, such as scrolling through the page, clicking something, typing when the key goes down, when the key goes up. So there are rules for how the HTML changes after it has already rendered. And these functions can be declared in a script tag or a reference to a separate file, just like CSS. So here's an example where I have put a couple of different styles in CSS here, just so that we can see a change happen. And then this is an example of a script in a function in a script tag. So this is vanilla JavaScript, you might hear it called, as in it's not using a fancy language or framework. It is just JavaScript that is interpreted by the browser. So I'm saying have this variable called box that gets the element with the ID myBox. So every time you see box here, it is referring to the element with the ID myBox in it. Change that style to yellow. Change that border color to hot pink. And then here we're getting a couple of other elements with specific IDs and changing the text. And finally, remove the button that is used to trigger this function. So here's how you would apply it in the HTML document itself. Make sure that ID is set that the script is acting on. Here are the other IDs where the script is going to change the text contents. And then here's a button with an on-click event to call that function. So when the user clicks this button, it will do what that function told it to do. So this is what it's like before you click the button. It has the gray background and the bright blue. Click the button, all those changes take place. The HTML has been edited, the browser renders it differently and shows you a yellow background and a hot pink border. So you will rarely see vanilla JavaScript out in the wild anymore. It's good to learn because it is what everything gets translated into, but people often now use libraries and frameworks instead. Libraries are sets of functions that can be used to build or enhance any interface. So somebody went through the trouble of writing all of these functions in vanilla JavaScript, and then they give you the function names. One example is jQuery UI, which is pretty popular. You might have seen some of these widgets, accordions, button date picker that makes a calendar show up dialog, that makes a window pop up with specific contents and so on. Frameworks are libraries, but have a very rigid structure. So they have standardized structures for deploying applications quickly, unlike, there we go. Unlike jQuery UI, where you would just call that library in the head and then you can use any of their functions, frameworks are pretty rigid. You have to use their particular structure for constructing a page. An example is Angular, which is used in Ex Libris Alma and will be in the Primo Next Discovery experience. AngularJS, which is the current Primo VE, is also a framework. So you have to use their components. You have to use their structure. And if you do anything other than that, it will break things. So frameworks are used to deploy applications quickly because it's always the same. And Wade is also saying in the chat that CSS frameworks exist as well. Yes, Bootstrap is a CSS and HTML framework. So people who are used to using this framework repeatedly will just use the same one for a new website, and you don't have to think about writing all this stuff from scratch. Backend frameworks also technically exist. Node.js is one of them, and that's used in the Primo development environment. If you've ever tried to write a customization for Primo, or you've heard about people writing customizations in Primo. So Node.js is something that you put on your machine, you download it, and then it constructs the web server to kind of act as your Primo generator instead of calling the real Primo out on Ex Libris' servers. Okay, now we're moving on to IP addresses. So previously we had client side, what a web page was made out of, and the different components that you might be examining or working with. Now we're going to talk about how computers communicate with each other. They contact each other by IP address. I'm sure everybody has heard the term IP or IP address. It stands for Internet Protocol, and it's the specification for constructing and assigning these identifiers. So there's actually two versions. IP version 4 is the one you're probably most familiar with. It's the one that has been around since the 80s or 90s. And it's written in dot decimal notation. You'll recognize it something like this: 35.82.168.182. Always 4 numbers. Each of these 4 numbers represents 8 bits. So it's a total of 32 bits. This is not knowledge you will ever have to apply. I think it's just good to know and understand what the difference is between IP version 4 and 6. So if you represent each of these numbers in binary, they're each 8 bits of ones and zeros for a total of 4 times 8, or 32 bits. This results in a pretty small set of possible IP addresses that could be globally unique. We have private IP ranges to make sure that people can do a lot of things without needing them to be unique. And those are used to communicate between machines within a local network. A local network could be your university, it could be a home, an office. So they always start with 10, or 172.16 through 172.31, or 192.168. If you are at home and you're trying to access your router to make configuration changes, it's probably set to 192.168.1.1. That means probably there are a billion 192.168.1.1s, and depending on which network you're on, it will contact a different machine, a different router. So to communicate over the internet, ISPs have to assign a public IP address that is globally unique. So that is a number that is outside of these ranges. And you can Google what a computer's public IP address is if you need to provide that to anyone, like your IT department or a vendor. When a vendor asks you for a computer's IP address, make sure you're giving them the public one, not one of these private ranges, because the vendor on their own private network, if they try to type in one of these things, it's not going to end up on the right machine. If you're talking to your own IT department, they might want the private one. But yeah, the easiest way to make sure you're giving them the right one is just Google it, because that will show you what somebody outside your network is receiving. The problem with IP version 4 is that it can only support 4.29 billion possible unique IP addresses. And that is way too small, because all of us now have multiple devices connected to the internet within our own homes, within our businesses, and it has already run out to the extent that these IP addresses are very expensive for ISPs to acquire and for web service providers to issue to their servers. So we now have IP version 6, which became the standard in 2017, and it looks different. It's not those 4 numbers separated by periods. It's a 128-bit space instead of just a 32-bit space, which gives us 340 undecillion possible unique addresses. That's 38 zeros after the 340. So that should give us plenty of room to work with for the foreseeable future. It's instead of those 4 numbers written as 8 16-bit hexadecimal values. So hexadecimal values are base 16 instead of base 10, like our usual decimal, and it uses 0 through 9 and A through F. And A through F represents the integers 10 through 15 in a single character. So here's an example of an IP version 6 address. You'll see each of these is a hexadecimal value separated by colons. You'll also notice that it looks similar to those values I was showing in CSS, because CSS for colors also uses the hexadecimal, with the F being the highest and 0 being the lowest for color values. So here's broken up what each of these hexadecimal values actually is in decimal. So you'll see down here, 8F00 has more decimal digits than the preceding numbers. So that's why we use hexadecimal to fit a bigger number in a regular space. And translated to binary, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, it should be 16. Yeah, so it's 16 times 8 instead of 4 times 8. Yes. So that gives you a lot of big numbers. You'll never have to do this. Only I did this for this presentation. It's just so that you can recognize the difference and why we do it. So notations with fewer than 8 values indicate subnets. So this is an example of a range, I tried to highlight it and it's a presentation. That was silly of me. So instead of all of those numbers, that full set of 8 there, it's 1, 2, 3, 4. Just 4 of them, and then it tells you that this is divided up. So this is a whole range of addresses that start with these 4 and then could have additional numbers out there. This is the range that is AWS assigned to the Orbis Cascade Alliance's web servers. So this is what you might have to provide to a vendor if your institution supports IP version 6, which not everybody does. In fact, very few people do. Here in Central Oregon, where I live, we don't have IP version 6 because the single ISP that we have serving the region doesn't support it. They just don't. So we here in Central Oregon can't use IP version 6 unless we're using a VPN or some service that allows us to. So according to Google's statistics, only about 45% of their users access services over IP version 6 as of August 2024. This is an old stat. This is last month. Less than half of people using Google are on IP version 6, even though it has officially been the standard since 2017. It just is not universally supported, which means websites need to support both protocols simultaneously. So when you're talking to vendors and they're asking what your IP ranges are, you might have to provide both. You might need to know both. Get them from your IT department, put them somewhere. So they might be asking what your subnet is for the range of on-campus computers, or you might be providing a range of IP version 4. But if you are setting up a web server, you can't give it just an IP version 6 address, because then your patrons are at home. They're in an area like mine that doesn't have IP version 6. I think like Eugene, University of Oregon does IP version 6. Springfield, right next door, does not. They only have IP version 4. So you need to support both for the foreseeable future. Domain name system, or the way that we avoid talking about IP addresses outside of when we have to configure something. The domain name system associates friendly host names, human-friendly host names, with IP addresses of their servers. On Windows, you can look this up. You can open the command prompt, which you can find just by searching your operating system for command prompt or CMD. It's called cmd.exe somewhere in the program files, and the command is nslookup. So if you were to type in nslookup orbiscascade.org, you're going to get this answer showing you the 2 IP addresses that I previously used as examples. Those are the address of our WordPress server. So before the domain name system was in place worldwide, maps of host names and their IP addresses were recorded in a file, just one file. That became really impossible to maintain after a while. But those files still exist on individual computers. If you have a Windows computer, it exists on your computer too. And it can still be used to define domains that don't exist out on the internet, so they'll work on one machine only. On Windows, the file lives under System32 drivers, etc. hosts. Make sure you're running a text editor as an administrator when you modify it, but that way you can add, oh, I didn't, I thought I had put an example in there, but you can see it on the lesson page of what that host file looks like. And you can say, this domain, which doesn't actually exist in the domain name system, like it's not real, goes to this IP address. And when you do this, you will likely run into security warnings that you have to bypass. So make sure you know that you're going to the machine you actually want. I have only seen one vendor, Ex Libris, ask people to modify the host file in order to test something before they launched it. And that was when they were applying a custom domain to Primo. But it's possible that you might have to do this at some point. But you will be running into security errors. And in November, we will discuss why that is. Security certificates. So zones and records. The zone is just a file that defines all of these domains, and it lives on a name server. So when somebody purchases a domain from a vendor, they will tell that vendor, such as Hover, we have at Orbis Cascade, that this domain needs to go to these name servers. Our name servers are on AWS. And then those name servers have these files that define what goes where. So they can contain several different types of records to direct traffic. A and quadruple A records associate a domain with the IP version 4 and IP version 6 addresses. When you, in that example of NS lookup before, those were returning A and the AAAA records. CNAME records associate a domain with a different domain that is usually in a different network instead of directly with an IP address. I mention this because you will likely sometime as a systems librarian have to set up a CNAME or tell your IT department to set up a CNAME. A very common application is setting up a custom subdomain for a hosted service like libguides. If you want your libguides to not be at springshare.com, but to be at mylibrary.myschool.edu, you have to set up a CNAME record associating mylibrary.myschool.edu with the SpringShare destination. There are other types of records that are used for email routing and authentication and verification of website ownership and so on. So we will cover some of those in the November session on security.